All right, we move on to our final speaker of the evening, who is Michael Langbein from the DLR, which is not the Docklands Light Rail, it's the German aeronautical service. So, Michael, you there?
Yes, I'm here. Can you hear me fine?
Yes, we can hear you. So, yeah, please, if you can share your screen.
Right, so wonderful. Hold on a second.
While he's getting set up, let me just remind everyone. So after the event, we'll do a vote on Twitter for the best speaker. So don't forget to vote.
Right, so you should be able to see my screen now, right?
Yes, we see you.
Wonderful. Okay, then I'll get started, which is not an easy task after a speech like this one. That was really amazing. Honestly, it was a lot of fun, Davis. So let me jump right in. This talk, so first of all, my name is Michael Langbein, as you already said. I'm working at DLR, the German Aerospace Center. And this talk is going to be about a project that we've been working on called RIESGOS, which is a project that aims to simulate natural hazards, things like tsunamis, earthquakes, volcano eruptions, things like that. And especially, it's going to focus on the core technology that we've been using behind the scenes in RIESGOS, which is an OGZ protocol called WPS, stands for Web Processing Service. And I'm going to jump into the nitty-gritty in just a second, but just as a brief overview, WPS basically enables you to do remote procedure calls. It's a SOAP protocol for distributed applications. That's basically the idea behind it, and how we used this protocol for distributed applications to build our project. That's the topic of this talk. So, all right, so here we go. About RIESGOS. A few words about RIESGOS. So basically, we're working in civil protection, and the idea is to use quite a large array of scientific models to simulate scenarios of natural hazards, like, as I said, tsunamis or volcano eruptions. And the purpose of this is to make it easier for decision makers to plan for worst case things, like imagine a really, really heavy tsunami hitting a coast town. And for people like mayors and police and hospitals and firefighters and so on, to plan evacuation routes and all kinds of eventualities. So that's a noble goal, more or less. But there is an issue to it, which is that unfortunately, natural hazards tend to be complicated. Especially the issue is that they consist very often of more than just one physical phenomenon. The slide that you should be seeing now is a schematic of a scenario that we're working on in a town called Valparaiso, which is a harbor town on the coast of Chile. And it's situated in a seismically rather active zone. And it's been struck by quite a few earthquakes in the past. And so imagine that a scenario might look like this. An earthquake hits the city, and that earthquake might by itself already cause quite some damage to the city, but it might get even more complicated than that, because the earthquake might cause a tsunami, which the tidal wave might hit the harbor and create some damage to the infrastructure there. Especially that would be bad if it's what we call critical infrastructure. Imagine if it hits a power line, which itself powers a hospital, which then needs to be evacuated. So things can get complicated really, really quickly, which is just the way the world works. It's just natural and fine with us. But the problem is that as scientists, we tend to think in a more reductionist way. We tend to think of focusing on one phenomenon and trying to model this thing well. It's basically a little bit Unix philosophy, isn't it? Do one thing and do that one thing well. So imagine there's a research group who's focusing on calculating the acceleration caused by an earthquake. And then there is a completely different research group at another university focusing on simulating the hydrodynamics of a tidal wave. And yet another group situated in a completely different country working with a whole other set of people working on the critical infrastructure. So if you are a decision maker and you want to take something useful out of all this academic research, you want to have a more holistic picture of the world. And what you want to have is a way to arrange all those models in a chain, to chain them together and to form a whole scenario that covers all the aspects that are relevant to that scenario that you want to simulate. In our case, this earthquake / scenario tsunami thing. Now that's basically what the WPS protocol provides for us, or it provides the facilities we need for this. It's enables us to expose scientific models to the internet. And you get, if you have a series of such models, then you get a cloud of services that you can integrate easily into your application. And that's really quite fun to do. You can mix and match. You can just pick out of the cloud whichever services that suit your specific scenario and build your application around them. So it's really like playing around with Lego bricks. You just pick what you need and recombine it the way you want. In other words, we've just basically have a neat little protocol on our hands to do microservice architectures. And that's basically what RIESGOS does. We've got a thin client here, which is our web application, which does all the orchestration of the web services, but does none of the calculation. All of the heavy lifting is done in the cloud by the services provided by the different research institutions and universities that host the actual servers. All right, so that's been quite a lot of talking and quite a bit of theory, so I guess it's much easier if I just jump right in and show you an example of how this whole thing works. So let me start here. This is a video you're going to see in a second, a video of one client that we've written. And it's really built it's really simple. In the center, you have, again, the city of Valparaiso. You can see Santiago down here on the bottom right and Valparaiso on the coast. And the important thing is on the left, there's a little widget called the configuration wizard, which is basically the user interface to configure all the WPS services that are out there in the cloud that we've got integrated in our application. So basically what's going to happen here is a user is going to pick an earthquake location and magnitude from the map and use it as input to one of the services. So here you see the user making a selection. And with that selection made, after hitting submit, a request is going to be made to the backend service. So you should see the submit button now, and now the service changes its color to yellow, which means something is processing in the background. And you see a little bit of a spinny widget thing here, which means that something is happening behind the scenes. And that little something I'm going to show you here in a little schematic. So again, you've got our front end out here, and it's making its request to the ground motion server in the background using the WPS protocol. And the actual scientific model kicks in and starts its calculation. Once it's done calculating, the result is going to be sent back. And it's all going to be happening in a self-describing XML protocol that makes it easy for us to see what kind of data format we are to expect to receive from that service. So with the new data back, we should be seeing the ground motion simulation data being displayed on the map in a second. And indeed, there it is. Let me pause this here for just a second. All right, so what you're seeing on the map here is a large green dot. This is basically the acceleration. Just a side note, that's not really important, but just as a side note, this is basically the acceleration of the ground that's been caused by an earthquake that has its epicenter at this little blue dot right here in the center. Now that's one of the reasons why WPS has turned out useful for our use case. It makes it easy to offload all the heavy lifting, all the calculations to the backend services. And it's really quite a handy thing to do distributed applications. But there is another benefit to it, which turned out really useful for us, which is that it makes it easy to chain services. In other words, it's easy for one WPS service to fetch its inputs from another WPS. And that happens very often when you've got scenarios of events that build on events that build on events and so on. So in our case, what we will run next is we want to have a tsunami simulation. So this earthquake hits the ground, and the shaking is going to cause a tsunami. And now we want to know how high that tsunami wave is going to be. So we're going to kickstart the tsunami simulation here. And this is going to start running. And then we know that the tsunami simulation is going to need as its input the output of the previous service. So what the protocol is going to tell the service is that, all right, you need to run, but you also need the input from the previous service. So it's fetching the input from the previous service, then doing its calculation, and then sending back the results. So it's all really rather simple, but it's been formalized in a way that's been really, really neat to work with. We've had decent experiences with it now. It's been rather easy to integrate more services. And that should be working in the application too. So once the results are back, we should be seeing the tidal wave height, the maximum wave height on different points around the epicenter. You can also zoom in a little bit and you'll see again the city of Valparaiso, and a little bit further north, the city of, I hope it's pronounced Con. And we've selected a rather heavy earthquake. I believe it was magnitude 8 or something. And you see that the tsunami has gone really far inland too. So it's probably a rather damaging scenario. But either way, those have been just 2 example WPS. But you can see in the list that there's quite a few more. In fact, only within the project of RIESGOS, we have currently available, I believe, around 24 different models exposed. And it's only going to get more. We are working together with a bunch of research institutions, a lot of them in South America too, of course, because obviously they're the experts on the kind of natural hazards they're encountering there. And so the cloud is getting bigger, and it's been really rather pleasant to work with too. So, and obviously, those WPS that are available within the project of RIESGOS are not the only ones that are there, but it would always be nice to see more available online. Like you find many websites that have lists of publicly available WMS or publicly available WFS. It would be nice to see more sites listing publicly available WPS services. And so joining that community is really easy because most of it is open source, including that demonstrator that I've just shown you now. It's open source. You can find it on GitHub. So if you do happen to have a model and you want to expose it to the world, which, by the way, doesn't mean that you need to make it open source. You can still keep it proprietary. It's just that it's exposed to the world and people can integrate it in their services. It doesn't mean that it can't. You need to make it completely open source. Either way, if you do want to expose it, there's already quite a list of WPS servers available. That's the list that you find here in the higher upper paragraph. Or if you want to integrate a service into your application, there's a list of clients, including ours down here in the middle paragraph. So WPS has really facilitated for us to build a distributed system. It does have its drawbacks, however. We have made the experience that even though it is a self-describing protocol, at times it doesn't contain quite enough information about the content of a file. It does describe the format that you are to expect, but not always all of the content. So you sometimes do have to do a little bit of data mangling when you're chaining one service into another, but overall the experience has been rather pleasant. All right, so my timer says that I've got 1.5 minutes left. So I believe that's time for questions. Thank you very, very much. Most of all, really, thank you all for all the talks. That's been really, really exciting. And I guess it's after you, Stephen, now, right?
Yep, it's back to me. Thank you very much, Michael. That was fascinating. So a couple of questions. The first one was about Earth observation in general. Somebody's asked, Earth observation is in a period of rapid technological advancement. What advice have you got for people who want to get involved in this area?
Oh, it's really nice that you asked that question now, because as it happens to be, there is a how do you say this? A competition happening at the moment. There is something called Copernicus and the Copernicus Hub, which is a site where ESA is publishing remote sensing data. And that competition is for everybody to sign up. They can download data. Everybody can always, at any time, download data for free from Copernicus Help. But right now, so there's that little competition going on. I believe there is a cash prize of 5,000 euro, something like that, for the winner, for anybody who writes a decent, useful application making use of that remote sensing data. So that's a really, really nice point to jump in. And obviously, there's many other data access points for that. You'll find most of it linked via the Copernicus hubs.
That's a great way for people to start. So,
it really is.
Question from a couple of people, me included. I wasn't quite clear when you were chaining two WPS services together. Is the input from one service to the next going directly, or is that going through your hub?
Ah, yes, right. That's the neat thing about it. So data can be passed per value or per reference, which in this context means that you just send, so per reference in that context means you just send a link to the data, and the link will point to another WPS. So you do not actually have to download the data through the front end, which would cause quite some network traffic that you want to avoid, but much rather the services can fetch the data directly from each other, saving you, the front end, a little bit of traffic, which usually is very handy for us performance-wise.
So you orchestrate it. In other words, you set up this service needs to get data from this service, which will answer this question, but you don't
Exactly.
have to handle the data yourself. You just get the results back.
Exactly. You do have to tell the server where it can find its data per reference. So you need to send the link, but you do not necessarily have to send the whole payload. You don't have to send all the data as data.
Brilliant. Thank you very much. Okay, Michael, that's great. Thank you. Thanks a lot. Ed, handing back to you now.